So what are we going to talk about today? First up, we're going to talk about what is Octopus and what is Pulumi. So what are the problems they solve and how do they make your life easier? Just a short introduction. Then we're going to jump straight into 3 demos. First up, Luke is going to go through how to create a Kubernetes cluster with Pulumi. And then second, he'll hand over to Michael, and we're going to look at how to deploy, how to integrate with a Kubernetes cluster and deploy to it. So integrating both Octopus and Pulumi at that point. And finally, we're going to have a final demo. We're going to look at how you can use Octopus runbooks and runbook automation to combine both Octopus and Pulumi to either provision or destroy new environments and infrastructure. You can do it on a schedule, and there's lots of useful scenarios there. And then finally, we're going to handle some Q&A. And so with that, I will hand over to Michael. And you can introduce Octopus.
Thanks, Rob. I'll just share my screen here. So a quick intro to Octopus. The 3 problems that Octopus sets out to help with are release management, deployment automation, and operations runbooks. And in Octopus terms, a release is a version snapshot of your application binaries, your configuration variables, and your deployment process. And in today's demo, your infrastructure as well. Octopus lets you model the lifecycle that those releases progress through, and it lets you see which version is in which environment at any moment. You can think of Octopus as taking over from where your CI server finishes. It takes the binaries that your CI server's built and manages and automates the release management and deploying of them. In terms of deployment, Octopus lets you model that deployment process with a nice user interface. And we'll see today why that's important even in an infrastructure as code world. It lets you specify things like which step should run in which environments, and you can model approvals and notifications, etc. And finally, Octopus lets you create operations runbooks. These are all those tasks which bring lots of value in automating, but that don't necessarily belong to a particular release. They're not the deployment process. These are things like restoring database backups, disaster recovery failover, provisioning and deprovisioning infrastructure, which we'll see in today's demo as well. Runbooks are perfect for these kind of things. And we'll see each of these 3 areas in action in today's demo. So the full life cycle of your application will involve a whole ecosystem of tools, and you should choose the best one for the job at each stage. Octopus integrates with a wide range of products, both before and after it in the life cycle. And today we're going to have a look specifically at how it can integrate with one of those, Pulumi. And with that, I will hand over to Luke.
Wonderful. Well, it's great to be here today to talk about Pulumi and Octopus. So before let me make sure I'm on the right slides here. Before I dive into exactly kind of what Pulumi is, let me talk about a little bit about. Looks like we got the slides reordered a little bit there. So before I dive into what Pulumi is, let me talk about kind of why, with the problem that kind of Pulumi is tackling and why it's potentially kind of interesting for you. So Pulumi is a modern infrastructure as code tool. And what that means is really helping you to deal with how you manage cloud infrastructure in today's kind of workloads. And one of the things we've seen is this sort of transition of cloud workloads over the last, maybe 5 to 10 years from very simple kind of VM-based workloads where most of the complexity was me managing what was running inside my VM. I was writing my, using my package managers, using my chef scripts, all those kind of things to make sure that what I was running in my VM was the right applications, the right supporting services, and all that sort of thing. As we moved into sort of the core, early cloud era, we started to bring in more cloud capabilities. We started to bring in potentially containers, potentially auto-scaling groups, potentially splitting things into some microservices. And now we've got a little bit more complexity in our cloud infrastructure, but we still own a lot of the complexity of running our VMs and managing what's going on inside those. In this modern cloud world, we're sort of unlocking all this value of the cloud platforms, all the managed services they offer, all of the high-level sort of compute platforms they offer, whether it's containers or Kubernetes or serverless. And one of the things you may look at the right-hand side and say, oh, this looks way more complicated. Why would I want this? And the main benefit is that I get to hand off so much of that operational burden to these cloud providers. And that's what unlocks all this value for me to focus on what matters to me. And you see those little gray boxes, sort of, those are the place where we've actually focused all of the effort. So now you only own these gray boxes. You don't have to own all the different stuff going on inside these managed services, and yet you get to build on top of it and use that value. The one place where this modern world is more complex is that now you have to manage those arrows. So you have to manage, how do I connect all the different pieces of my cloud infrastructure together to build up this more complex cloud native application. And that's exactly where infrastructure as code comes in. Infrastructure as code is the arrows. It's how do all my pieces of infrastructure relate to one another? How do I evolve them? How do I add new pieces? How do I version them? All those different pieces are part of what we need to do when we manage modern infrastructure as code. And so you may be thinking, if you're familiar with this space, you're thinking, oh, I know about infrastructure as code. That's CloudFormation, that's Terraform, that's a variety of these other tools that are out there today. And one of the things with most of these existing offerings is that they really are focused on sort of more infrastructure as text. They're based on the idea that we can take this, we can make it text, we can put it in source control. That's great. That has a whole bunch of benefits. But when we think about infrastructure as code, we really think about more of infrastructure as software. What are all those benefits you get from code and from software engineering that enable you to scale up your application development? How can we bring all those benefits as well into these more complex cloud infrastructure environments? And that's things like versioning and testing, the ability to have IDE completion and error checking and shifting left a lot of that complexity. The ability to build reusable components and to share those. All of these pieces that we're sort of familiar with as we think about software engineering, bringing that to bear on the infrastructure problem as well. And so with that, what is Pulumi? Pulumi is a modern infrastructure as code tool. Pulumi targets any cloud. So we have support for around 50 clouds, both major clouds like AWS, Azure, GCP, and Kubernetes, but also the long tail of additional things like Cloudflare or Postgres or anything that you might want to work with. You can manage all of that through a single pane of glass. Pulumi enables bringing software engineering capabilities to infrastructure as code by letting you use familiar programming languages and tools. So we let you use TypeScript and Go and Python and .NET to actually describe infrastructure and then get all of the tooling benefits of those ecosystems to use. And then by being a tool which sort of bridges between application developers and infrastructure teams, we help bring those teams together, help give application development teams more tools to directly work with the cloud, and help give infrastructure teams more software engineering capabilities to scale up the complexity of what they're building. Pulumi is fundamentally open source, and most of what I highlight today will be open source, but we do have a SaaS offering as well for teams and enterprises who want to use that to manage across their team and across their organization the deployment and delivery of these workloads. And so with that, let me actually dive straight into a quick demo to give you a feel for what Pulumi looks like in practice. And I'll focus in my demo on using Pulumi locally for sort of developing and delivering from my machine. And then I'll hand over to Michael in a bit to talk about how we can take that same application and go and deploy it continuously using Octopus. So let me start. I'm going to actually start by creating a Kubernetes cluster in AWS here. But to begin with, I'll just start with something more simpler, just to give you a feel for what this looks like. So here I am inside my IDE. I'm in VS Code in this case, but I could be inside any IDE. And because we get to use existing programming languages, existing tools, I can get all the benefits I would expect from my IDE environment here. And so, for example, here I can say I want to create an AWS S3 bucket. And you'll see in each of these, as I went through that, access to the entire surface area of AWS. So every resource that's available inside the AWS platform is available to use from Pulumi and to compose together to build up my applications. When I pick a bucket, for example, it's one of the many resources in here, but I see rich IDE information inside my IDE about how to use this resource, common patterns, that sort of thing. And of course, when I create my bucket, I get access to all of the different capabilities this has all right inside my IDE. And so I can go and use any of those properties that I want. But in this particular case, I'm not just going to create a bucket. What I'm going to do is create something more interesting. Like I'm going to create a whole virtual private cloud inside AWS. And so if you've ever done this yourself, you've done this with CloudFormation or with some other tool, you know this is actually quite complex. I've got to provision 30 or 40 resources. I've got to create both the VPC itself, the subnets, the route tables, all the different pieces of infrastructure. But with Pulumi, because Pulumi is just code, and so we can use other reusable components here. I can say new AWSX.ec2.vpc, And this is actually a higher level component that knows how to create a best practices VPC using everything that AWS describes as the common patterns for what you should want to do and how you should set up a VPC. And it lets me provide just some very simple high level configurations. So instead of all the different properties I might have available to me from the raw AWS APIs that I just showed, instead I can do things like, hey, I just want best practice VPC with 2 availability zones. Very simple, and I can just go ahead and deploy that. So I'm going to come down here, and that's it. I've described that the desired state of my cloud infrastructure is just to have this VPC. So I'm just going to say Pulumi up. Pulumi up is going to deploy the infrastructure I have. It's going to make sure it matches the state that my program described. And so in this case, my program wants me to have this VPC. And we'll see the first thing that Pulumi does is it previews this deployment. And so it tells me what's going to change in the cloud when I do this deployment. And what it says is going to happen is it's going to actually create 31 new resources, exactly those things I just talked about, the VPC itself, the subnets, the route tables, and a few other things. I can go ahead and say details to see the exact details of what it's going to create. And if I like what I see, I can say yes to go ahead and deploy that. All right, so this is going to take a couple minutes. Let me highlight a couple of things while we wait for that to deploy. So the first thing to highlight is, we did that deployment locally. We did it from our local machine. But we're actually able to see the status of that deployment and the history of my deployments and all these things in the Pulumi service here. So the Pulumi service is a free offering for individuals and then has paid offerings for teams and organizations. And it gives me the ability to sort of understand the full history of my deployments and manage those across my team. And so in this case, I can see the activity that happened on this deployment. I can see the history of all the deployments. In this case, I've only done one. I can see for this same project that I've got, I've developed, I've done previous demos, as you can see, of this. And so I can see all the other previous demos that I've done, how many resources deployed, when I did those demos, that sort of thing. And, we can even come and see higher level things like, what updates have I done recently? How many resources do I have under management? All these sorts of things. So lots of capabilities for understanding what's going on with my applications. The one other thing, and I'll just dive back to that, that we can see if we look at this, is we can actually also see all the resources that are being managed by this stack. And so in this case, we've got that VPC, we've got that net gateway, all these different pieces. We can even see them in a graph here. And if we wanted to dive straight into the AWS console to go see that particular resource that we're now allocated, we can click this link and deep dive into the AWS console. Okay, so while I wait for that to finish, let me do the next step to create an EKS cluster. And so to do that, we can say, const cluster equals new. And we actually also have a high-level component for working with EKS. So EKS is Amazon's managed Kubernetes service. And I can just create one of these. And again, I could use the raw resources inside AWS and inside Kubernetes and work with those. But in this case, we have this high-level component, EKS.cluster, which lets me, with just a few lines of code, create a best practices EKS cluster. And so in this case, I want to say that the VPC I want to run in is vpc.id. And the subnet IDs are the VPC's public subnets. So just passing a couple of pieces of information from the VPC to the cluster, and now I can stand up an EKS cluster inside that subnet. The last thing I'll do is I'll just say export const kubeconfig equals cluster.kubeconfig. And this is just going to let me export out the kubeconfig, which lets me access this cluster from other tools. So if I now want to use, kubecontrol or some other tool to deploy a workload into my cluster, I can do that by accessing this kubeconfig. So, okay, we saw that previous update completed. And so I've deployed now my VPC into AWS. What I can do now is say Pulumi up to deploy the changes. And you'll notice I use the same command. I'm just updating to this new desired state. But now my desired state includes a cluster as well as a VPC. And so what we'll see now is that the preview shows that many of my resources are unchanged because I didn't have to change any of those networking resources. So I had 31 unchanged resources, but I have 27 new resources. And it tells me I'm going to output this kubeconfig once it's available from the deployment. So I'll go ahead and say yes, and this will start kicking off that deployment to go and create that cluster inside AWS. Okay, so there's a very simple example of standing up a cluster, just a few lines of code, because we're able to build on top of the foundations of some higher level libraries. And you can build these libraries yourself and share them within your organization to encode your best practices as well. So the one other thing I want to highlight, we've sort of a Kubernetes cluster there, but we also want to look at Kubernetes workloads. So if I want to deploy something into a cluster, either that one we just created or one locally on my machine, we can do that as well using Pulumi. In that previous example, I was using TypeScript. In this example, I'm going to use .NET with C#. So Pulumi has access to, you can use TypeScript, you can use Python, you can use .NET, you can use Go. And so this example, for folks who have worked with Kubernetes, you may have seen the Kubernetes guestbook example. It's one of the oldest examples, one of the very first examples that they put out on the Kubernetes docs. It's a very simple example that runs a few containers inside a Kubernetes cluster. And so in this case, we're just going to run a Redis master. So we have a Kubernetes deployment. And just like we could access everything in AWS, we can also access everything in Kubernetes from Pulumi. So pulumi.kubernetes. I can take the apps namespace. I can take every version of that namespace. And then I can look at all the different resources that are available inside the Kubernetes APIs. In this case, we're just going to work with a deployment. That deployment is going to run the Redis image, pass some default values. I'm going to create a Kubernetes service to expose that, to expose port 6379. And then I'm going to run a Redis replica as well, which looks very similar. I'm not going to expand these two because they're pretty much the exact same thing as above. And then it runs a front-end web service. And so in that case, this is just a simple PHP app and exposes the IP for that. So you'll see that this is really pretty much, if you did this with Kubernetes YAML or with Helm chart or something, it's going to be pretty similar. It's going to be this 250 lines or so, a lot of boilerplate, a lot of the same patterns here. But you get to write it in exactly the same way, with the slight benefit, of course, in Pulumi that if I make a mistake like I did here and misspell something, I get that error immediately. I find out about that very quickly. What's better, though, in Pulumi is that I can get rid of a lot of that boilerplate by factoring it out, just like I would with any other software project. If I had a bunch of boilerplate, if I was repeating myself too much, I'd say, hey, no, I want to take this pattern, give it a name, and reuse it. And so in this case, we've done that. We've taken that exact same program, still in .NET. We've just factored it out and factored out all that commonality into a class called service deployment. And so now we can just say what we mean. We want a Redis leader with this image and these ports. We want a Redis replica with this image and these ports. And we want a service deployment, and we want a front-end web service with this image, this port, and we want this one to be exposed to the internet so we can access it. So there we go, much more at the right level of abstraction for the problem we're trying to solve. And so we can see that just like before, we can say Pulumi up. And what this will do is go and deploy this stack right here. And by default, it'll deploy to what my local Kubernetes context is. Let me just see. I don't think maybe I hadn't saved that file. There we go. Okay. So there we go. So we're going to create 10 resources, basically the deployment and service for each of these things. We say yes, and just in a few seconds, this is going to deploy that all out to Kubernetes. One of the things we'll see as we deploy this, we actually get a lot of context about what's happening. And so the deployment has been created, but it hasn't yet stood up all the containers that are expected for that deployment. And so Pulumi is telling us it's going to wait for all those deployments to actually succeed, for the pods to be stood up and to be responding as healthy. There we go, that initialized, and then we create the services. We're looking for the pods to direct traffic to, waiting for those to be healthy endpoints for the service. And it should just take a couple of seconds, and this should deploy. All right, so there we go. So now we've got this running on localhost. So if I come over here to localhost, we now see we have a guestbook running. So we can run Hello Octopus. We can refresh our page, and we've still got that running inside of our Redis instance. So we've got a simple application deployed to Kubernetes with Pulumi. We could even go and deploy that into our existing cluster there. So one last thing I want to touch on, because it'll be relevant as we think about how to map this into Octopus, is the notion of stacks. And so for this given program here, we can have multiple copies of it stood up. We could have a development environment that I use. We could have a staging environment. We could have a production environment. And each one of those is a stack. And so we can actually come and look at how many copies of this I have stood up right now. So I have 4 different copies of this running. And each one of these can be running in a different environment, deployed with different configuration. And so, for example, this right now, I can see the config. I have no config specified for this, but I can specify some configuration. So for instance, one thing we could do is just say var Redis image. config.get. And now we've made this, instead of hard coding this image here, we've actually made this configurable. And so now if I, say the Pulumi config set Redis image, I won't actually deploy this because Redis 2 is not a real image, but I could change this to be something else. And just like, for example, here we replaced the Redis replica with one that is our own. We could do that, or we could set a specific tag on that image or whatever we want, so that we can deploy a different image based on this configuration. That would mean that in different environments and different stacks, we could have different images or different tags for the images deployed. And so this is a very simple way to stand up multiple copies of this. And while everything I've showed so far is me delivering it locally from my machine, what's really interesting is when we go and move this into a continuous delivery process, move this into a production environment that's going to be a long-lived environment. And for that, we need to partner Pulumi with some continuous delivery service. And Octopus is a great way to go and embed Pulumi in and put that continuous delivery around it. So I'd like to hand over now to Michael to show us how we can do that.
Thanks, Luke. And I think that is the perfect place for Octopus to pick up the story. We might actually start at the end here and work backwards and dive into some of the details. So in this sample project, you can see we've modeled 3 environments. We have a dev, a QA, and a production environment. And right away, this is a nice chance to talk about a couple of things. The first is that this kind of visibility, being able to see which version of the application is in which environment, is even in an infrastructure as code world, still really important. And secondly, the concept of environments, as Luke mentioned earlier, maps really nicely onto the Pulumi concept of stacks. So let's create a new release. And a few interesting things here. So in this release, we have 3 packages that we're going to include in it. The first of these packages is actually a zip file that includes the Pulumi project. And the reason we have this is that, imagine you're using the Node.js version of Pulumi. We're assuming here that it might be your CI server that runs the npm install and packages all that into a zip file and sends it to Octopus. Or if it's the .NET flavor that gets the NuGet packages and bundle those up. We could run all of these as part of the deployment, but as a general rule, we always like to encourage the build once, deploy many times mantra, and this fits the model as well. And it also saves some time running this on your CI server that we can shave out of the deployment time. And as we'll see later, when you're deploying to cloud hosts, particularly things like Kubernetes, anytime we can shave from the deployment is a win. So, okay, we've got our zip file as the first package. These next 2 packages here are actually container images. This one is the Redis image. This one here is our application image. And again, the way that would typically be created is it would be the CI server that built the application, ran a Docker build on it, and published the container image to be consumed by the release. So, but these, although they're container images in this case, they could just as easily be zip files or Maven packages or anything else if we were deploying to, say, an Azure web app or even directly to an EC2 instance. And I actually think this separate here but really explicit versioning of the infrastructure, the dependencies and the application code all together is actually really nice. It's pretty compelling. Okay, so let's create this new release. And we'll deploy that to our development environment. And we'll leave that to run, and we'll come back to that in a little bit. In the meantime, let's dive into the deployment process. So this is another chance to show how a tool like Pulumi and Octopus complement each other, because again, while modeling that infrastructure and that deployment of your application in code alongside the application code is really compelling and makes a lot of sense, a typical deployment pipeline will also have other steps that don't necessarily fit as well to be modeled as code inside the application. Specifically here, we can see at the start of our process, we have an approval step, and at the end, we have a notification step. And the reason why it might make more sense for something like this to be modeled in your delivery tool rather than in the code is just a separation of concerns. It's quite likely that your application developers are the ones who will be implementing the actual deployment logic of the application itself, whereas the people who care about compliance issues like this, like approvals, may be a completely separate group of people. There's also just the, I guess, the permissions concerns around this as well. Again, it offers a nice chance to split between the people who can modify the deployment of the application, the Pulumi demo that Luke showed earlier, versus those who can control the approval to different environments. And again, just being able to see this deployment process here and visualize it, it helps to radiate that information again beyond just the folks who read and write code. But let's jump into the interesting part for today, which is the point where Octopus and Pulumi meet. So we'll dive into this Pulumi up step here. This is the step where Octopus invokes Pulumi, and it's actually worth calling out at this point that we actually have a step in our community library which the Pulumi folks contributed, and it's a great place to start in most cases. For today, for our educational purposes, I haven't used it, but if you are doing this yourself, I would definitely recommend at least looking at it to base your own implementation on. What we've done here is added this step, and the type of this step is what Octopus refers to as an AWS CLI step. It's essentially just a script step, but it runs in an authenticated AWS context based on a selected AWS account. If we have a look at the actual code of the script here, you can see that we use a Pulumi access token that comes from an Octopus variable, which we'll take a look at in a minute. We select a particular stack, again, based on an Octopus variable. And let's just actually dive over to there and take a quick look at these variables. So this is, again, one of the values that Octopus brings to the table, is being able to control the changes in these values across different environments. So what you can see here, for example, is these are those AWS accounts that I mentioned earlier. And a pretty common scenario is to use one account in your test environments and then segregate that with a different account in your production environment, which we've done here. That Pulumi cluster name that we're going to use is actually based on the Octopus environment. So we're going to name this based very closely on the name of the Octopus environment we're deploying to. You can see we've configured the container images we're going to use, the access tokens, which again are different across the environments. So let's jump back across to the step. And this Pulumi up command, which is where the magic happens, you'll see we specify the stack config file. And this is worth diving into a little bit. This will be included in the zip file that we've bundled with the Pulumi project. And we can have a look at this. So rather than have a different Pulumi stack config for each environment, in this case, what we've done is created a single stack config file for Octopus. And you'll notice it's actually a template. It has parameterized values in it, which Octopus will inject with the correct values depending on the environment being deployed to. And this means we'll get the appropriate values for each environment. So what actually happens at deployment time, it runs a little like this. Octopus will extract the zip file containing the Pulumi project and that Octopus stack config template. Octopus will then run variable substitution, which we've configured here on that Pulumi stack file, injecting the correct values. We'll execute our script, which runs the Pulumi up command. And then finally, we capture a couple of output variables here. And we're going to use these in a second. And these are based on, you saw Luke earlier export the Kubernetes config. These can be done in the same way. In this case here, we've exported the cluster URL that's just been created and its name as well. And that's the crux of the integration between Octopus and Pulumi. But there are a couple of interesting little side alleys to explore here. The first of those is one of the real challenges in modeling a deployment like this is just getting the right versions of all the tooling dependencies that you need in place. Even in this Kubernetes guestbook example, which is a relatively simple example, we needed Pulumi, we needed kubectl, we needed the AWS CLI, we needed the AWS IAM authenticator, we needed Docker, we needed Node.js, we needed the .NET framework, and probably a bunch of other things that I'm forgetting about too. So this can actually be pretty painful to get set up correctly. But there is a technology that makes this a lot easier, and that's container images. So on this step, we've taken advantage of the Octopus feature called execution containers, which lets this entire step execute inside a specified container image. And this is based on a custom image that we've built for this demo. And we can take a look at the Docker file for it. We won't dive into the details of it, but it's actually based very heavily on Pulumi's published Docker images, in this case on their FAT image, which contains everything you're likely to need in it. And that was a really nice way to get started with running this. I'm sure if we put some effort in, we could trim the size of this down. There's probably things in here we don't need, but for getting started, it was pretty quick and easy. And you'll notice we've specified the tag in here as well. So the person who modifies this deployment process has full control over the versions of those tools, which is a pretty nice story. The next thing to call out is the fact that for this example, we've combined the modeling of the infrastructure and the deployment to it in that Pulumi project. So it's both creating the Kubernetes cluster and deploying to it. But there's no reason, of course, that these things have to be tied together. We could certainly pull them apart. This really comes down to how you want to model it. But since they are tied together here, what we'll show is in this third step here, this ugly little bit of bash is actually emitting an Octopus service message. And what it's telling Octopus to do here is to create a deployment target in Octopus based on that Kubernetes cluster that was just created by Pulumi. And we can actually jump over to our infrastructure page here in Octopus, and we can see these Kubernetes cluster targets have been created. And it will keep those updated every time that deployment runs. And this is pretty neat because it means that we can reuse that dynamically created target from other places. And this is just my clever segue to talk about runbooks. So let's jump back over here. So as we mentioned earlier, runbooks in Octopus let you model all those jobs that don't fit in the deployment process, and they often revolve around infrastructure, specifically things like provisioning new infrastructure, destroying infrastructure, making configuration changes, scaling, all of those type of jobs. And Pulumi is all about infrastructure, which makes Octopus runbooks and Pulumi a really natural fit together. In this case here, just as an example, we've created a runbook which deprovisions that Kubernetes cluster that we've created. And we can take a look at this. It does this. Again, it's just a script step, and it delegates all the hard work of tearing that cluster down to Pulumi. So again, it selects the relevant Pulumi stack and calls Pulumi destroy on it and removes that stack. And actually, that's a nice place for us to jump across into the Pulumi console, where we can actually see these Pulumi stacks that were created by those deployments. So this is the development stack that we were just deploying earlier, and we can see those values that have come in. And we can jump back over here. And let's finally jump back to our deployment, which has hopefully completed now. It has. And that runbook to destroy the infrastructure, you could easily imagine configuring that to run on a schedule. So for your test environments, for example, it tears that Kubernetes cluster down each night so you don't pay for it, and it'll just be dynamically recreated again the next time you deploy the latest version, which all makes for a pretty compelling story, I think. So hopefully we've seen today that Octopus and Pulumi play really nicely together. I personally find this a really neat integration and makes for a really nice story. And with that, I shall hand back to Rob.
Great, thank you. I'm just sharing the slides again. Give me 2 seconds. Okay, great. So thank you, Luke and Michael. I think that was great. And I think it really shows off the power and the problems that both Pulumi and Octopus solve. So now let's jump into a couple questions. So just double checking our community Slack. There weren't any questions there. We've had 2 great questions in Zoom. There still is lots of time if anybody watching has any questions. So
Rob, there actually is a question in Zoom. Oh, yeah, sorry. Yep.
Oh, yeah, I was just, thank you, Michael. I was just going to ask that.
Apologies.
One. So Mark Fletcher asks, one pattern in AWS is rather than having credentials for different accounts, you say have a tooling account that's able to assume a role in your dev, QA, or prod accounts that has the necessary deployer policies. Can we do this with Pulumi and Octopus?
Yes,
Yeah,
definitely.
Yep. You can go first, Michael. Yeah.
No, I'll let you go, Luke. I'll take over after you.
Sure. Yeah. So definitely, I think the answer is yes for both, and I think both provide their own answers, and then those answers can also compose well together. And so for Pulumi, there's a lot of different ways you can authenticate to AWS. When I was doing it locally on my machine, I was just using my ambient profile that I had set up. The profile I was actually using when I was doing those deployments was an example, just like you say here, where I was actually assuming a role from one account into our particular dev sandbox account that we use locally for kind of doing demos like this. And so it was doing exactly what you're suggesting, but there's a wide variety of different patterns you can use for how you authenticate in AWS or any of the other cloud providers you might be working with. And so those can be different depending on whether you're in your local environment or potentially ultimately when you're in something like Octopus. And that turns over then to how Octopus manages providing those credentials into the environment when the deployment's happening there.
Hey, Rob, can I share my screen again for a sec?
Oh, absolutely. Give me 2 seconds. Over to you.
Thank you very much. So what you actually do in Octopus, each step can be configured to run on a different worker pool. And those worker pools, in this case, I've used the hosted worker pools provided by Octopus Cloud, but there's nothing at all to stop you from creating your own worker pool and bringing your own infrastructure for that. And it's a pretty common pattern to do that and to use, in this case, AWS EC2 instances as those workers, and they can be configured to use that role-based access of the EC2 instance, just as you mentioned. If we actually jump back to the deployment process, what that would look like is we would have chosen a different worker pool here. And in the AWS account, we can assume a different service role, and we can also execute using the service role of the EC2 instance if we want to. So that is, yeah, as I said, a pretty common pattern.
Fantastic. So I'll just switch back. Oops. There we go. Oops.
To answer the second question in Zoom as well, Mark asked if, he says, I assume this works nicely with Azure using an Azure account set up in Octopus 2. And yeah, it's exactly the same as the AWS example, just substitute Azure everywhere where we said AWS, and you can use an AWS VM in exactly the same way.
That's great.
Yeah, and similarly from a Pulumi perspective, we focused in the code there on AWS, but all these same sorts of things, access to 100% of the platform APIs that are available, access to the strong typed libraries, the ability to create these reusable components on top of it. All the benefits we kind of talked about there are also true for Azure. One of the most interesting things I think there is also that, hey, you can combine AWS and Azure, or Azure and Kubernetes, or Azure and Cloudflare, or, the sort of all the different combinations of different platforms. You can have a single pane of glass to work across all those different cloud platforms.
And the neat thing about the Kubernetes example is switching between the two is not a whole lot of work, right, Luke?
Yeah.
Just a quick follow-up. So today we've looked at Kubernetes, but I guess my assumption is both Octopus and Pulumi do support technologies other than Kubernetes. Kubernetes is a lot of it's the modern and popular technology right now, but a lot of companies have mixed support, VMs to just a range of infrastructure exist, and a lot that they actually have on-prem that they're shifting to the cloud. Michael and Luke, can you comment on how Octopus or Pulumi can support such a transition or environment, or do they support like a hybrid environment?
Yeah, so from the Pulumi side, Pulumi supports, both a lot of different cloud providers, but also all the different cloud technologies and different things are available within those cloud providers. So if you want to work with EC2 instances and VPCs and that sort of level of things, using Pulumi, lots of folks using Pulumi at that level. If you want to work with serverless, if you want to work with ECS and sort of core platform native containers, if you want to work with Kubernetes, all those different platforms are available, plus all the data technologies, all the storage technologies, all the analytics technologies, just everything inside the platform. And so yes, there's a wide variety of use cases, and I think you can kind of mix and match those things in very natural ways. I'd say in terms of kind of helping with sort of transitions, Pulumi does also offer easy ways to sort of migrate in, either to coexist with existing things. So, hey, if I've got a CloudFormation deployment already, I can start using Pulumi to manage that CloudFormation deployment. And so I don't have to go and rewrite that thing in Pulumi or change it. I can just kind of start managing it that way. Similar, if I've got an ARM template, we have tools to both manage those ARM templates in Azure or to actually convert them, automatically convert them into Pulumi code. We have a pulumi.com/ARM to Pulumi that will just paste in your ARM code, we'll give you back a Pulumi program that deploys the same thing. And then we also have the ability to adopt existing infrastructure. So if you've deployed something by pointing and clicking in the console, but you want to now bring in sort of that infrastructure's code layer on top of that, but without disrupting any of what you're currently running, you can also do that. You can say, I've got this infrastructure I know exists, generate me some code to represent that existing infrastructure. And now I'm going to manage updates to it using Pulumi and using that sort of infrastructure's code approach instead of by continuing to point and click. And so all of those are sort of tools to help you kind of modernize and bring a lot of your infrastructure, if it's grown complex, under management with a sort of modern infrastructure's code tool.
And yeah, from the Octopus side, Octopus has in-the-box support for a whole range of technologies, like Kubernetes, like we've seen today, but also Azure, deploying to IaaS applications, Docker. But anything that we don't have in-the-box support for, we also have a community library with about 400 different steps in. And failing that, as we actually saw in the example today, anything you can script yourself, you can also run via Octopus. And actually a lot of the value that it brings is pretty agnostic to what's being deployed. All that release management functionality doesn't care what's being deployed underneath it. And yeah, certainly self-hosted virtual machines as well is where Octopus grew up. So it certainly handles that scenario as well.
Yeah, that's excellent. We have another great question that's just come in from Mark Fletcher. And he asks, in the example, we use Pulumi to create the infrastructure as part of the main deployment process. If this step was moved to a runbook, decoupling the management of the infrastructure from deploying the app, are there any drawbacks or gotchas to be aware of?
No, actually, I actually think that is probably how you would model it exactly like that. It was really just for simplicity of the demo that I didn't model it like that today. I think that'd be really neat to be able to provision the infrastructure as a runbook. You could even configure that to run every morning or however you liked. And your deployment process could even invoke that runbook if you wanted to run it or just do the same. But no, the runbooks, and in fact, even if it wasn't, the neat thing about the way Pulumi works is the way it maintains the state. It can detect the differences between what's currently there and only apply the changes that it needs to. So you can even invoke that create infrastructure as part of the deployment, and it will just bring it up to the state that it needs to be. And then you can also run it individually from the runbook if you want as well. But there's a whole lot of other scenarios that I think make a lot of sense to model as runbooks as well. Things like scaling out the Kubernetes cluster. Imagine you did a Canary deployment to a Kubernetes cluster and you set a certain amount of traffic through your ingress to your Canary pod, having a runbook to be able to update that percentage of traffic to eventually get it to 100. Yeah, there's lots of pretty neat scenarios that would be fun to explore.
Yeah, say from the Pulumi perspective, just to add one thing on that. I think the two patterns that we showed here are both totally valid patterns, kind of for using, kind of deploying both together, both the sort of cluster and the application workload together, and kind of using the runbooks to stand up and tear down the clusters. I think there's sort of a third option, which we see a lot of folks do with Pulumi, which is really having two separate kind of environments, one for the cluster and one for the application. and manage them both as long-lived, long-lived environments inside something like Octopus, where now as I'm making changes to my cluster, I can sort of push those out and deploy those independently. And that might change some configuration of my cluster. Like maybe I add some baseline managed services into that cluster, or I add the ability to handle storage volumes or something like that. Not things that don't disrupt the workloads running in there, but that sort of evolve the sort of state of my cluster itself. And then I have an independently versioned pipeline for how I deploy changes to my application workload itself. And so we could then have both of those be independent sort of deployment pipelines through something like Octopus. But then those might make sense for a long-lived environment versus the Runbook model, where it might be more for something where I'm kind of spinning up and tearing down, and I want these things to be more short-lived, for example.
So Luke, in that model, you'd have two separate stacks in Pulumi, one for the infrastructure and one for the application deployment?
Yeah, two different projects, and each of those their own stack. And yeah, so.
And we actually see a similar pattern in Octopus too, where you end up people creating operation-specific projects that just contain the bunch of runbooks to maintain the application. And the reason I think that people do that is twofold as well. Number one, it's just a separation of concerns. Like Luke mentioned, the people who care about the application deployment aren't necessarily as focused on the infrastructure side. And also it lets you nicely segregate the permissions, because again, the people who have permissions to spin up, imagine it's your production Kubernetes cluster, the group of people who have the permissions to tear that down is probably a small subset of the people who can deploy to it. So that fits really nicely.
That's great. And you actually answered my next question, Michael, but I really think that the Runbooks is that's almost an ideal integration point between Pulumi and Octopus. I see that as a really exciting part. We have a couple more questions. First, Vern DeHaven has a question. He's asking, since using worker containers requires elevated privileges for Docker in Docker when Octopus is running in a managed Kubernetes environment, which is disallowed in GCP Autopilot, for example, can we instead use external worker pools to host these containers?
Yes, is the answer. As long as the external worker pool that you bring yourself has Docker installed on it, that will work just fine.
Excellent. And we've got a great question from Robert Montgomery for both of you. And is there anything exciting that you're able to share from your roadmap? Now, I know Pulumi, for Luke, Pulumi has an event coming up, which we'll mention a bit later. So I don't know if he can give us any sneak previews, but Luke, if you want to go first, and then Michael, if you can share anything exciting coming up.
Yeah, no, as Rob mentioned there, we have our Pulumi Up conference is coming up on April 20th, so fairly soon now. We're going to be kind of announcing a few new things. In particular, kind of we've just started the sort of betas for our Pulumi 3.0. And so we'll be kind of announcing some of the big pieces of Pulumi 3.0 there, but also some other new news. So definitely come and join that if you're interested in hearing a lot more about Pulumi, in particular Pulumi 3.0, which is coming soon.
Michael, what's exciting on the Octopus roadmap?
Thanks, Robert, for giving us a chance to talk about the roadmap. That's excellent. So soon in Octopus, things we've got coming out are the ability to import and export projects between spaces, including across Octopus instances and into Octopus Cloud. This has been something that many people have asked for a while now. We have a config as code, EAP, coming out later this year, which we're pretty excited about. We have updated support for Azure App Services. That'll be available in our next release. We have GitHub Actions that we've built that integrate with Octopus. I think that's about it for the moment.
That's great. Let's do that. So that's great. There's no more questions. I do have one more question for Luke, and it's probably related for Octopus down the road, like once config as code is available. But do you have any advice? How do teams organize their infrastructure as code? And they often keep it alongside their application code, or do you find they create repos dedicated to infrastructure only. And it's that same thing with Octopus, where you can have them side by side or have them separate. And so do you have any advice for people watching?
Yeah, it's a great question. It's a little bit related to kind of what we were talking about a few seconds ago, but I think it's a even more kind of fundamental question. And one of the ways I think about this, Pulumi supports kind of a variety of different patterns for how you structure things. And one of the ways I think about it is sort of similar to the microservices versus monoliths sort of debate in kind of service design. And I think that the general, maybe some zealots for either end of that spectrum might disagree with this, but I think the general, advice there is, hey, as long as it makes sense to keep something as a monolith, that's going to be simpler, right? You're going to have one versioned unit. Everything's going to be able to talk to each other. You're going to be able to sort of move quickly in that model. But once you understand where versioning boundaries exist, where teams are working independently on different parts of that code base, where there's a well-defined interface between two parts of the system that you can sort of tear apart and formalize as a sort of interface boundary, then it makes sense to split those things up and have those evolve independently. And I think a lot of the same things apply for kind of your infrastructure. You're going to have a lot of infrastructure if you're building kind of a modern cloud-centric application. And that infrastructure is going to be similar. There's going to be some pieces which are tightly coupled and are going to want to version together. And the fewer units you can have that are versioning independently, the better, all other things considered. But once you have two independent teams that are versioning totally separately, and Michael also brought up some of the permissions issues and some of these things, there's going to be good reasons to create boundaries and create different versioning subsystems. And once you do have things versioning independently, now you might want to have those be different code bases so that they, so the permissions again can be different, so that the pipelines around those can be different, that sort of thing. And so we generally see folks start with a simple model. They've got one code base, it sits next to their application, it versions largely with, their application workload. But as they get into more complex sort of team structures and versioning structures, then they start splitting that up as it makes sense based on the structure of their organization.
Yeah, that's great. I think that makes a lot of sense. And so we don't have any more questions. So Luke and Michael, unless you have something final to say.
Only that this was a lot of fun, and I think it was a really neat story too. So thanks.
Excellent. So we'll just plug along. And two key resources for the webinar, the examples that have been used. So as two you can see here. The first is GitHub repo for the examples that Michael used in his demo. And there's the matching sample Octopus instance, which has guest mode enabled as well. So you can take a look at those, poke around, they'll be live, and take a deeper look. And finally, that's it. Thank you very much to everybody who watched, who attended. Again, we will send an email to everybody with a recording of the webinar. We do publish it to YouTube again, so you can check that out and share it as well. And I will mention two additional events. So the first, which we already alluded to, so Pulumi Up is on April 20th. And so that's a big event. It's got some great industry speakers, as well as I think there's going to be some exciting announcements from Pulumi. And the other one is Octopus's next webinar. And so that one is on April 21st, our next webinar Wednesday, and that's Continuous Delivery with Dave Farley. And if you don't know Dave Farley, if you don't recall his name, he's one of the co-authors of the Continuous Delivery book with Jez Humble. And so they're going to talk about how to enable fast feedback with continuous delivery for high quality releases. And so there's two great events coming up. I encourage you to check them out either at octopus.com/events or pulumi.com. And yeah, without anything else, say thank you very much to Luke and Michael, and we'll wrap up.
Thanks all.
Thank you.